And that should be doing that. And I will share my screen. Good. And you should all be able to see that now, which is good as well. So thanks everyone for coming along to Not So OT. It's been a little while since we had one of these. So thanks everyone for coming back. Just before we get going, we do have a code of conduct in place here, which there's a lot of words on that screen, but really it boils down to just be nice to each other, be polite and patient, and no such thing as a silly question and things like that. So if anybody does feel as though anybody's breaking this code of conduct, then just send me a direct message in the Zoom chat, and we'll get to the bottom of that and sort it all out, so everybody feels nice and warm and welcome. So thanks to our sponsors. Normally, if we're in person, we'd be sitting at the Rebel offices in Nottingham, but we're not. We're all in our houses for this one in particular, but soon we will be back. So continuing to thank Rebel. Calix, all be well, will be sponsoring a piece of IoT kit, which I will ask David to choose after this, actually. So something in the region of between 30 and 50 pounds normally, so well worth getting. So I'll talk a little bit about that in a bit as well. JetBrains are also helping us with a free JetBrains license, which I'll talk about. And then my still existing consultancy company is footing the bill for everything else. So that's why that gets a mention. As I said earlier, JetBrains, if you don't know who they are, they make developer tools for developers. So things like JetBrains Rider and IntelliJ and WebStorm, PHP Storm, tools like that. Really cool stuff. So if you want to win a 12-month license to any one of their products, then do just tweet on the hashtag NotsIoT, and at some point after this I'll go and choose a random tweeter, and you may well win a JetBrains license. In fact, there's a very good chance, because I think I've got quite a few that I need to use, because it's been quite a few months since we've had one. I've stacked up some codes, so it could be that there's a good chance that at least 4 of the people that are on this call could win a JetBrains license for 12 months. So well worth doing. You've got a very good chance of winning that. And then one lucky person, if you tweet again on the hashtag NotsIoT, will win a piece of IoT kit courtesy of Calix as well. So do that, tweet about what you're seeing and what interests you and stuff like that. Make sure you use that hashtag and you've been with a chance. As I mentioned earlier to a few folks, there's at least 2 MVPs and 1 ex-MVP on this call. If you don't know what that is, it's a program initiative by Microsoft to reward people that are active in the community, talking or organizing or helping with open source in and around the Microsoft space. So if that's something that interests you, if you're interested in community-bound content like this, then do come and speak to myself if you like, but you can also approach Sander, and Stephen is an ex-MVP as well, and I'm sure he'll be interested in talking to you if you've got some questions about that. So tonight we've got David Pacman talking about giving personal robots personality with generative AI, which personally I'm really looking forward to. And David will be on in a few minutes' time after I finish waffling. Upcoming meetups has actually got nothing after it for this month and next month rather, but the month after that in November, we've got Peter Shaw, or Shorty as he likes to be called, and he's not doing a talk on TBA. He really just doesn't know what he's going to speak about yet, and he's got just a couple of months to get that written and done. But they're always fascinating device level talks that he gives, so that'd be well worth checking out. And with that, we're done with my slides, so I am going to stop sharing. There we go. And I'm going to hand over to David. While we're doing that handover, by all means, come off mute and just ask questions while David's giving his talk, or use the chat and I'll do the interruptions. But obviously be cognizant that David's speaking, and try and choose an opportune moment if you're going to do that. And again, don't forget to do those hashtag NotsIoT tweets to be with a chance of winning some stuff. And with that, I'll switch over to David. So thank you very much. And I think you might have your headset turned off, David.
When I'm sitting here talking, my lips are moving, but you hear nothing. That's probably a sign. So, hi, I'm David Pacman. How do I describe me? I think in the most uh, well-known video I've ever been in. I've been called Robot Nerd. I'm a former program manager with Microsoft. And I've been working on building robotics and social robots in particular for about 5 or 6 years now. Ask anybody at Microsoft for the hackathons and at the garage. I'm always famous for bringing robots everywhere. Um, so today we're going to talk about, of course, robots. And robots, I mean, I'm sure you probably know, are pretty much just IoT devices for the most part, especially most social robots that do anything conversational. Um, so it's easy to sort of transfer the same capabilities across to other IoT projects, whether you want to build a talking refrigerator that tells you that you need to buy new beer, um, or a microwave that sings it's getting hot, 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 whatever you want. Or the beer chiller that tells you what beers are left in your underground cavern. So as I said, let's keep things sort of light. You can feel free to break and interrupt me if you want me to elaborate on more things, or if you have a question as I go through. Let's see. I'm really going to try to keep things simple here. I'm going to talk about social robotics and AI and what they have to do with each other. Then we'll sort of dig into a little bit of detail about, hey, why would you want to use AI? What AI would you want to use? Where would you want to have it? And all that different fun stuff, because there's more than just ChatGPT out there, and there's more than just the conversational AI that you're probably going to want to dig into, right? And then we'll start giving some demos, talk about some code, and show you some of the robot friends I have, and maybe have them answer your questions if you want them to. They're probably more of an expert than I am. So what is social robotics? Social robotics is basically creating devices that give companionships to humans, right? And there's a lot of research behind it about how um, not just people maybe that are neuro um, that aren't neurotypical respond better to robotics when learning how to socialize or communicating for therapeutic reasons, or whatever have you. But they're also very efficient at helping address feelings of loneliness and social isolation. Right now, at least in America, and I know a few across Europe too, we're in what's called an epidemic of loneliness, especially following the COVID pandemic and the isolation that we all went through. And the nice thing about social robotics is that it's conversational. You could talk to it. It's an animate object, which is, studies show it's much better than talking to a screen. That in addressing feelings of just isolation. So it gives you something animate, something real to connect with. And of course, the thing is that it should only be used as a tool to help bring you back or refresh your socialization skills so that you feel more comfortable talking to people, because there's nothing that can really replace that people to people connection, right? Of course, there are some exceptions. Some people are actually like homebound, or don't have the opportunity to go out and socialize, and here's where social robotics really comes into play. There's some notable examples. Jibo, probably the most prominent one, which sort of ended on a sad note when it sang its goodbye song a few years ago. Cosmo, Vector, Luna. There are actually many examples out there, to varying degrees of success commercially or whatever have you. So why should you care about social robots? Well, as I mentioned, social robots are really just IoT devices, right? At least for this audience here. Um, and integrating AI into IoT has a lot of different uses, not just conversationally with large language models, but machine vision, things like that, natural language processing to take verbal commands as an alternative to pressing a button or whatever have you. Also, I should mention that social robotics is a growing market, estimated currently at 7.3 US dollars. billion US dollars, and with an average 25.5% growth rate year over year. This is just that study. Those statistics were done before ChatGPT became a big thing, because so that's going to really have a major effect on the market for AI in robotics and IoT. Why? Why AI? Well, obviously large language models. What's better than having a conversation with your car um, or whatever have you? It can give you information that's understandable, and you can reply to it, and it can understand you conversationally. This is particularly important in social robotics, but it also has applications in IoT as well. Of course, for those that don't know, large language models or natural language processing models are trained on really large data sets. We're talking uh, gigabytes, like almost some models are hundreds of gigabytes in size, using what we call a generative pre-trained transformer architecture. Basically, what this is doing is it's tokenizing the language, right? So it converts words, sentences, phrases into numbers, and it does predictive um, modeling on those combinations of different tokens to determine, when it's given a prompt or information, what words and phrases and which tokens should come next in sequence, right? So you're basically talking to a calculator that's doing some really interesting algorithmic probability calculations on what it should respond with. So large language models are the most well-known AI at the moment. Just what's hot. And it's basically a way to make devices more conversational. Um, counter to a lot of sensationalist articles and media things out there, it's not conscious, right? It doesn't think on its own, even though it's pretty convincing sometimes, especially when it hallucinates. And for those that don't know, hallucination is basically when a large language model makes things up in response to a query, and what it makes up isn't necessarily factually correct, right? This happens a lot when a model encounters something that it hasn't necessarily been specifically trained on, or information that it doesn't have. It'll make up an answer because the programming tells it to be helpful and come up with an answer, come up with a response. And it will do that even if it has to sort of make it up. And probabilities tell it that these phrases should come next because something similar it saw on the internet, conversation or something like that, had this sort of sequence in it. And it's really interesting to see sometimes how it does hallucinate and make things up. So that's one thing if you're doing it commercially and you're including your own data set in your model and fine tuning it, that sort of do a lot of testing to make sure that it covers all the questions, or at least it has a graceful way to back out and say, I don't know this. So while ChatGPT, OpenAI's sort of implementation of a large language model is the most popular and well-known one out there, there are actually a lot of different large language models. In fact, there are probably about 500,000 of them out there right now. A large majority of those models are based on Google's, or I should say, I think it was Facebook or Meta, the Llama model, which was released back in like 2018. It got loose out in the public, and everybody's been making models based on the Llama model since. But there are other well-known models out there, like Google's Palm and Palm 2, which is the basis of Bard. There is Meta's Llama 2. There's a lot of them out there, not just counting the open source ones like Vicuna, Red Pajama, and others like that. So some of these offer APIs so that you can access them without having to put the model right on your device, which is what's really, appealing for using it in IoT devices. But some actually can be run locally, and some can be run on commodity hardware like NVIDIA Jetson, or even an Orange Pi 5. And I'll get to that in a little bit, whether you'd want to do that or not. Also, beyond just large language models and generative AI, there are also other really important AI models, as I've talked about, machine vision, cognitive speech, other image models, and even ones that'll make music for you based on a text prompt. So that's some pretty exciting stuff. Now, whether you'd want your refrigerator to make up songs for you is another question, but to each their own. So where AI? Where do you want to put the model? What model do you want? Do you want it locally on your device, or do you actually, prefer to access it in the cloud? There's some trade-offs there. Personally, for me and my devices, I prefer to use them in the cloud through APIs, because mostly it's the resource cost of running a model locally. That has a big impact, especially when I'm working with, I try to keep things really small. I want my devices to be portable, handheld. I want them to be able to come along with their companion on their journeys in life, right? When you put a model locally on a device, it ramps up the resource cost. You need a more powerful device, right? And a powerful SBC to run it. That requires a lot of battery power. It requires a lot of thermal resource. It generates a lot of heat. So, that's one of my main reasons. And also, honestly, you're going to get a faster response, less latency in your responses using an API, as long as your network connection's reasonable, versus having a local model. It allows you to use more powerful and accurate models. When you put an AI model on a device, you have to do different techniques to compress that model to make it fit and make it respond in a reasonable amount of time. And that means taking away some of the capability that model has, some of the information and the way that it processes that. And it's easier to maintain. Honestly, you don't want to have to send out a 100 GB update to your device versus just a small update to the code to get it to use a newer model, right? But running a model locally on a device does have some benefits, right? Mainly privacy, right? I don't have to send the conversation over the internet. I don't have to worry about having what I talk about to that model being used to train the next version of that model, right? So there's a lot of benefit in that having a model locally as far as privacy is concerned. Now, there's things you can do to improve privacy controls using a cloud model. You can use a local LLM or one of the open source ones, in AWS or something like that, so that you have control over what happens to that data in the model or how that model is conversing, versus using like OpenAI's ChatGPT model through their own API, right? So there's some mitigations you can do there. And of course, it's resilient to network outages. If you're running that model locally, you don't have to worry about your network connection. But then is it really an IoT device? And of course, lower recurring costs. You're not paying per token. You're not, paying to use that model over somebody else's services or hosting provider. Which AI should you use? So I said there's a lot of different ones. If you're talking about specifically just LLMs, there's OpenAI, most infamously ChatGPT. There's different ChatGPT flavors. There's ChatGPT 3, 3.5, 4. Honestly, for you know, what I do with AI and what I rely on large language models to do, um, you know, I could use easily one of the more performant ChatGPT 3 models, and that's actually what I started out with using. Um, some are more expensive than others depending on the model size and the provider. Of course, Microsoft Azure, they have OpenAI on their services too, but you can also use their cognitive vision, or what they're calling Azure AI Vision now, or AI speech or cognitive speech. And in fact, I'll go through some code about that, and that's what we're going to be using here. Google Bard, Palm 2 is their latest iteration of that. And it's actually a pretty decent model. It is a little less constrained as far as some moderation that they have inside the model than the OpenAI ChatGPTs, which are heavily moderated. And we'll get into that a bit here. Then, of course, just stability, stable diffusion is a famous sort of image manipulation model or a series of models, and that allows you to do things sort of like Dolly 2, but you have more capabilities for text or prompt to image creation. You have prompt guided image editing. You have image enhancement and other things like that. And I actually use some of those capabilities in my robot, so we'll go over some code for that as well. And as I said, there's over about 500,000 other models out there. And if you want to access those, you're really going to want to get into Hugging Face. Hugging Face is basically a hosting service for AI models. And you can go there. If I could send out the links or whatever for that are in this deck, or send out the deck later to give you the links to those. But you're really going to want to get into that when you start wanting to experiment with hosting models, using some of the open source models or even some of the commercial models. I know Llama 2 is there. So the only way to really use that is through a different hosting service, because you can't access Llama 2 from Meta. They don't offer APIs or anything like that. So, but there are other hosting services that do, like Octo AI or Octo ML, which is another hosting service for AI models. And they have their own sort of implementations there. So you can go and try Llama 2 there. You could try it for free, but you can also host your own models through their services as well. So now I want to talk about some of the robots that I've built that you may know about if you follow me on the LinkedIn or whatever. Clippy GPT was a project that I made back in February of this year. Basically, it's a desktop assistant that uses ChatGPT. When I built it, it used ChatGPT 3.0 ADA model. And it basically, answers any question you have. It'll converse with you, have little conversations, and it'll sort of wiggle its little eyebrows whenever it's talking or signaling that it's ready to listen to you. It'll also display what you're talking about to it on a screen. So you can, if you're vision impaired, you'll hear the conversation, but if you're hearing impaired, you can see the conversation. Right. It's coded entirely with Python. So it's really easy to port this code or use this code snippets and other projects that you have. And that was the point of me making it with Python, because it was basically made for a developer relations video from a Microsoft developer or Reactor Let's Get Personal Computing series. So basically, I talked about this idea that I had about making an intelligent Clippy, or a smarter Clippy than it used to be. And if you don't know Clippy, it's an old AI tool with the old version of Office years ago before AI. And it popped up and annoyed you a lot. But this one was a bit more helpful. We had a video about it, and I made it in a week. That's designing the 3D printed parts, printing them, assembling them, putting the electronics together, and programming everything and testing it out. Basically, it costs about $200 to build US. and you can do it yourself. I have the instructions out there on Hackster.io, along with all the downloadable files, the support files, the code, all that fun stuff. So if you want to take a little toe dip into AI and IoT, there's your chance. Uses a Raspberry Pi 3B, so the compute isn't really heavy on that. You can actually use any other SBC out there that's Linux compatible, at least as long as it's Debian Linux. Ubuntu, I used Azure Cognitive Speech with this, and it doesn't play nice with Ubuntu. You're going to want to use Debian. I think they might have updated it though, so I think Azure Cognitive Speech might be able to run on Ubuntu now. I haven't tested it though. In this build, I use a Adafruit Cricket hat. And basically, what all that is a sort of Pi hat that allows your Pi to interface with servo motors, stepper motors, gives you touch capability. It has audio capability, so it sort of expands on Raspberry Pi capability. But after I built Clippy, I decided I wanted to take it to the next level. And this is where BMO AI comes into play. And BMO AI is basically a robot that I made based on a cartoon character on a show called Adventure Time. This one currently, actually, my version that I have personally uses GPT-4 and Palm 2, but the version that you can build on your own uses GPT 3.5 in the code. It has the capability of using DALL-E 2 for image variations. It does stable diffusion, text to image creation. It does photo manipulation. So you could take a picture and transform yourself into a cartoon hero or whatever you want to do. Has a lot of nifty little fun things that you can do on it. It has conversations with you, of course, and can do QA pairing. The parts in this cost about $250 US to build. And again, it's written in Python, and I'll go ahead and get into the code on that. Before I switch things over, are there any questions or anything that anybody wants to ask?
Yeah, Sander had one. Sander, did you just want to come off mute and ask?
If I can find the button, yes. Yes, well, I'm not a native speaker in English. I'm from the Netherlands, so I speak Dutch, which is a strange word for a Dutch language. But I'm wondering how non-English models are performing compared to English, or maybe even the different dialects. UK English, US English, Canadian, Australian, New Zealand, maybe. I'm not sure. Can you say something about that?
So I know there are some models trained on other languages. I don't think that they've really progressed too far, at least in models trained on native language, right? So there's a difference between a model that can translate English to other languages and back and forth in order to allow that communication with that localization, as we call it in the industry, with people that are speaking non-English languages, which are most models are trained on English, of course, versus a model that's actually trained on a different language. So instead of using a data on that's English, it uses data that's Dutch, like if you trained a model that is Dutch, right? I believe that there's only a couple languages that have been that's been done with, and that's because you're still sort of basing things sort of on English in order to get the tokenization to work. So basically what they do when they create a native language specifically trained model is that you basically find a data set that is a good translation of the same data in English, right? So let's say you wanted to train the model in Dutch, you would have to find different sets of conversational data that has a good match in English, right? And then train that with Dutch, and then you'd have a model that could speak native Dutch, right?
Okay.
So I mean, this is why I sort of talked about Hugging Face, right? Because if you wanted to undertake something like that and train your own model based on a different data set, right? Then you could do that there, right? Um, that's where a lot of this sort of work is happening. It's not happening with the big corporations and their large models. It's happening with open source models. A lot of the work and a lot of the advancements that are going on right now are people with their own open source projects where they're taking a model and training it on different data sets, right? That's where a lot of these llama models come up, where they just take the llama model and they just use different data sets. They use different parameters on that model to create something that's sort of new. I should have sort of talked about this is that, when models are trained to work on something like a local device, there's actually a lot of changes that you make to that model and its data set, right? You quantize the model in order to compress it. You do things like you take out some of the floating point precision of that model to make it respond faster on a device. You use less compute, right? The same thing sort of applies here. If you're going to take a model and use a different data set to train it, using a different language, then that's what you would do, right? You would take it to a local model and you would do that. You wouldn't, try to do that to like ChatGPT on Azure or things like that. Does that make sense?
Yes, it does. It's all about the data set that is available. And of course, my language is not spoken by that much a large group of people in the world. In the Netherlands, it is, but not in the world. So yeah, I think we have to hope that somebody stands up in the Netherlands and start working on that data set.
Yeah, I mean, again, you can use some, ML localization or ML translation services to sort of still talk to models, right, in your native language, but then is it really precise? And,
No.
exactly, right. If you want a precise sort of conversational model or response to your spoken language, then you're going to want to train that model in that language instead of relying on localization, ML translation to do that, because ML translation just, it's decent. It's been getting better gradually, but I've actually used it at Microsoft when I worked with chatbots there to do real-time localization. But the model itself wasn't localized, right? If you wanted something that's actually localized, then you're going to want to train it on that data.
Okay, thank you.
Mm-hmm. Anything else? Cool. So let's get into some code here. Now I use Python. Python's a pretty, oh, Peter.
That's a really bad reaction. That's supposed to be a clap, but it kind of looks like my hands up, doesn't it? So
see,
yeah.
You know me, I'm used to Teams. When I see a hand, I'm like, oh, I got to stop. Somebody has a question.
Yeah, it kind of does look like that, doesn't it? So apologies, that's my fault. Well,
no, it's okay. So I like Python. Python's great. Python's popular. It's easy to use. And most of the AI models out there and AI services out there support it, as do a lot of different IoT devices, especially SBCs. So here you can see I'm importing a bunch of stuff. The OpenAI SDK, the Azure SDK for cognitive speech. I use Pygame for my display on my device. You know, I should probably stop here and show people what this is doing. All right. Let's see here. Stop sharing. You're going to see my face for a bit. Maybe if I can make it focus on me. So this is BMO AI. Hey, BMO.
What's up?
How are you doing today? He's been waiting so patiently. I think he just got tired and went to sleep. Let's see.
That was that 13th slide, you see.
Yeah, I think so. It had too many beers.
Quick, turn it off and back on again.
Well, that's probably what I'm going to do.
Yeah.
Let's go ahead and do this. But anyways, let me go back to the code and then I'll bring him back up again. So anyways, we're loading a lot of different libraries here. Some are for the speech to text and text to speech using Azure Cognitive Services. Pulling up the actual SDKs for the AI models for OpenAI. And for the stability, the stable diffusion. And some for the camera, the Adafruit Cricket. This one here, I know Peter had questions about. He thought it was TikTok, but it's actually TikToken. And this one is actually pretty important when you start talking about the difference between QA completions and actual chat, contextual chat specifically, where you actually have a conversation back and forth with the AI, and it keeps track of what you're talking about. So for example, if I'm talking to my AI and I just do a simple completion and say, hey, how many different breeds of cat are there? And it answers the question. And then I ask, hey, which one's most popular? It'll say, what are you talking about? What popular what? You know, because it doesn't have the context of what came before it. When you start maintaining context of a conversation, what you're doing is actually in the prompt that you send your large language model, you're including all the conversation that came before it, so that it has awareness of what you're talking about. So then if I ask it, hey, what's the most popular breed? It knows I'm talking about cats because that was my question before. But to do that, the problem is that a lot of large language models have token limits. They can only hold so many tokens in their response. Back then, models were limited to about 1,000 tokens. So you had to really keep careful track of your tokens when you're sending that context back and forth, and each response consecutive adds to that token count. And TikToken is a special program that counts tokens, because tokens aren't just words or characters. They can be a word, it could be a couple words, it could be a phrase, it could be a lot of different things of varying sizes as far as how we interpret that conversation. But the numeric value of those sort of phrases and words is what the token really is. And trying to calculate that manually or programmatically is very difficult. So there's an actual library API that does that for you and counts the tokens, so that what you can do when you have that conversation. And here, let me show you how that works. It's right up here. Okay. So as you can see here, I'm setting token limits, right? I'm saying at each response should be 300, but the token limit total for the entire conversation should be 16,000. Now what this does is then it sort of counts how many tokens you're using in that conversation for each sort of consecutive turn, right?
Not sure you're sharing anymore, are you? Are you still sharing?
Not? Oh,
I'm not
here,
sure.
let me fix that. Thank you for letting me know.
That's all right.
I'm sitting here just talking to myself saying, here, look at what I'm looking at. You can't see
At least
it.
it can't be wrong.
That's right. Okay. So can you see my screen now? All right.
Yeah, that's all good.
Okay. So sorry about that. So here's what this sort of code snippet's doing is that when I tell my robot I want to chat, it's going to go ahead and start passing that context back and forth, right? And each time that I respond, it responds, it's going to append that response to the conversation. And that total conversation is going to be the prompt each time I reply to the large language model. So when I say, hey, how many different breeds of cat are there? It appends that to the conversation and response is appended to it. Then my response of, well, what's going to the most popular is added to it. And then its response is added to it. And it keeps adding the tokens as it goes, right? But when it hits 1600, it's going to error out because it hits its max token limit. In order to prevent that, tick token counts those tokens, right? And when it notices that you've hit your limit or close to your limit, it removes the first part of that conversation that it started with and starts removing responses after that. So each turn gets removed as another turn is added when you start getting close to that limit, so that it still maintains context in the conversation, but doesn't run out of tokens. So this is the method that we use to have a conversational chat with a large language model. Now, there's some other techniques that you can use when you start talking about vector databases and semantic cache and things like that. But this is a really simple way to sort of have a conversation with a large language model, especially when you're now talking about token limits in the tens of thousands versus a limit of 1,000 tokens, which is actually fairly small. In fact, when I built Clippy GPT in our video, you'll see an example of it hitting a token limit and cutting off its response to a question that the host asked, asking it to recite War and Peace or something like that, which would have been an insane number of tokens. But that's what tick token library is for, to allow us to count tokens when we start talking about having an actual conversation with the robot. And all those libraries I was talking about, here they are. When you're, again, all this code is available on Hackster.io on that link that I'll send out for the build. The next thing you're going to do after loading your libraries, reporting your libraries, is sorting out all of your keys, and all that fun stuff, because each of your AI API services are going to require a different token or different key in order to utilize. There's some other parameters that you're going to want to use globally anyway, so I sort of just put them all sort of in one place when I code things. But yeah, whatever way you want to do it is up to you. You think if there's anything that really stands out here? I'd imagine some of you have already played with Azure Cognitive Speech. This is one of the things that I really love about it, is the neural voices, because they do allow for some emotive expression, right? And this is what really gives the social robot some sort of personality, right? Because when I use an exclamation point, oh, go ahead. Does somebody have a question? No.
Yeah. There we are. You can come off mute, Greg. Greg, if you had an actual question, then you can come off mute. I'm not sure. I think Greg just reappeared back in the meetup, so I ended up. Yeah, but Sandy, you had a question that you've written there.
Yes, there was a demonstration of that little robot. It had some too much beer, But
You or the robot?
it had to, yeah, it had to wake up again. I've seen similar devices, like a pet in elderly homes to comfort, to accompany elderly people. But what other groups, apart from nerds and the people like us, what other group of people are expected to have a conversational AI robot at home?
So I mean that's a great question, and as I sort of alluded to at first, is that currently we're sort of in an age of what the U.S. Surgeon General calls an epidemic of loneliness, right? In the U.S. at least, and I know that some other European countries are also experiencing this. Studies show that about 76% of Generation Z, which is 18 to 24 age group, are feeling persistent feelings of loneliness or social isolation, even after the pandemic, where we were forced to isolate. So a lot of people are having trouble getting back into the rhythm of socialization, or just never had the chance to actually get into it in the first place. Now, this is sort of contrary to what you would expect, that it would be the senior age group that would have the highest percentage of feelings of loneliness, and a lot of them do, but for different reasons, right? While there is a lot of interest in our market research that we've done with seniors that are homebound, or don't have family that visits them often, want a robot like this, want something that they can talk to and converse with, and have fun with, play games with, and things like that. It's actually the youngest age group that has the biggest problem with loneliness, is receptive to, instead of talking to their device and social media and screen time, which is a big concern for them, having something that's animate, having something that's physical that they can talk to, that responds, right, is much more appealing than talking on Twitter or things like that, which they're actually very averse to. In fact, a large portion of that Gen Z cohort are switching from smartphones to flip phones because they're just so tired of all the screen time and the ill effects of social media. So a device like this, which isn't social media, right? It's having personal conversations with you. It's allowing you to conversationally get information instead of reading it and spending that screen time on it, right? That this sort of device would appeal to. So what do you think about that?
What I think about it, well, yes, I understand this, that people are lonely, and maybe the younger people, they can go beyond the fact that it's a box, that's a lifeless object. They can say, okay, I accept that it's for me, it's living. It's like a cartoon, but they can go beyond it's this silly box from plastic and some hardware. But I'm not sure how many people are actually in this group. Isn't this a niche, a really small market, or is it actually, yeah, they said it's a pandemic of loneliness, or epidemic of loneliness. It's hard for me to grasp that that's actually so many people who are having problems with this.
It came to a surprise for me when I was looking through the research that's been done and all of the polls that have been done and all that data, to get back that I expected it to be the senior cohort that would have the biggest problem, because they're either stuck at home, they've already lost a lot of family and friends.
Yeah.
They're stuck in institutions or things like that. But actually, they report the lowest amount of or percentage of population that feels persistent feelings of loneliness or social isolation. And I think part of that is also because, hey, they're in institutions or like group homes or senior living care facilities where they have other people to talk to, that they're in their age group. They have the caretakers with them and things like that. So I think that's part of why that percentage is actually really low.
Yeah, there's
Plus,
always there is a social net of people around them. Maybe they are still a bit lonely, but they are not physically lonely. There are people around them.
So the thing with Gen Z, though, the youngest cohort, is that, you know, their parents are still working, and work life, at least here in the US, is, you know, much more than 40 hours a week usually. So parents don't have time to socialize with. There's looser family connections, right? So they don't have that social network to hold it together. They're out of school. They're not taking classes anymore. They're working from home more often. They're spending more time on the screen instead of talking to others. There's a lot of different reasons, a lot of different factors, I think, combine to make that generation feel very lonely. Now, the thing about how we're sort of thinking about, at least my startup, is thinking about using social robots to address that, is that it's not a replacement for talking with people. It's a mechanism to sort of get people to start talking and then start talking to each other. We want to sort of develop a lot of programs that bring those users together, right? To do special events at different locations because of the visual capabilities of the bot. Hey, come here and take a picture of this and you'll get a prize, right? Come to this landmark here and things like that, and meet up with other people.
Oh, that's a smart thing to do, yes.
Yeah, because I mean, even though there are use cases where the robot's going to be that person's only social connection, right? If you're homebound, let's say you're bedridden, right? You don't get the opportunity to go out and talk to other people. So this would be a case where a social robot would be your companion, your sole companion for the most part, aside from a caretaker that comes in once a day or something like that to take care of you physically. But outside of those sort of special niche cases, right, where you're talking about a normal person that just, you know, feels socially isolated, doesn't know how to jump back into socialization, or never really had the opportunity to go out with friends and do things, right? You want to have something to help guide them into that and show them that, hey, you can go out, you can do things, you can have a conversation with a friend, you know, and your friend can help you figure out things to do and have fun.
Yes.
Because I think another factor is that a lot of people just don't trust each other enough to build those social connections. And that, like I did when I was younger, right? We didn't have the social media thing where people like trashed on other people and just, you know, the whole thing was about, you know, making people feel bad and trolling people and all that fun stuff. You know, I think there's a lot of use cases for social robotics that can help alleviate that and get people feeling more comfortable talking to each other, trusting each other, using a same sort of common reality almost, right? Where, you know, if I want to talk to my robot about, you know, hey, I heard this, you know, conspiracy theory, is it true? Right? And your social robot can actually, you know, help you figure out that, no, that's not what it is, right? Or this is actually means this, not that. And give people a common sense of reference, right?
Yeah.
Because it's really hard to communicate when you don't have that.
I love the idea that people do not only talk about against this AI, but they are taught, they are companions in their journey towards life, and that they are actually starting meeting actual people using the AI with a social game or a meetup or something like that. But I think you first have to break the boundary of the AI to have that working properly.
Mhm.
And then you can start doing that second step. Is that?
Yeah, and that's sort of the point. I mean, we're not the only people, we're not the only company that's integrating AI with social robotics. There are others. But the problem that I've seen in the industry and the approach that's been taken is one, a lot of these companies design their robots in ways that aren't appealing. You don't want to have a conversation with them. For example, there's a company out there that built a social robot that is basically just a decapitated human head that's transparent and displays a face on the front of it electronically. And I don't want to talk to it. I love robots, but I don't want to talk to it because it's sort of disturbing. It's so far down into the uncanny valley that I don't want to climb down to talk to it. There are other ones that, you know, Elon Musk, right? He's building robots. Have you seen his Tesla robot?
Yes. Yeah.
It's scary. I wouldn't want that in my home. The movement is an uncanny valley, but it's designed to be intimidating. It's not
That's,
designed to engage conversation. It's not designed to elicit a social response, right? So some of the key things that you need to do when you want to have somebody to talk to something is to design it in a way that makes them want to talk to it. That is cute, that's endearing, that isn't intimidating, and doesn't creep you out, right? So those are some of the design considerations. I'd sort of take it a little bit further. I want it to be portable. I want
yeah.
people to be able to take it with them wherever they go.
But
And
does that mean?
make it well. So here's the thing that I do. I take my robot wherever I go. Personally, right? Just yesterday, I went to fix my car. My car getting fixed takes about 3 hours. So I went on a walk. I stopped at a bar. I had a beer, right? People coming up to me, what is that? Right? What's that do? What's that for? So I show them. I have a talk to them, have a conversation with them, draw them pictures. It draws people pictures, right? It'll take a photo of you and transform it. It'll do a lot of fun, engaging things. But the primary thing is that it talks to you. And you can talk to it. You can ask it anything and it'll answer you.
But
People love it. Everybody in all sort of walks of life, not just nerds like me, right? And that's what's fascinating about it. Everybody's like, when's it going to be available? How much is it going to be? I want one.
it reminds me at the story of this hitchhiking robot a few years ago.
Yeah, and that there's a lot of studies on sort of aggression against robots and things like that, and that
Oh,
is a major thing that we need to sort of address, especially in America where there's a lot of robot phobia, right? There's a lot of negative feelings about robots here, where versus Japan, where you know culturally, a lot of their media showed them in a positive light. Here in America, in the Western world, media has shown robots in a pretty negative light. You know, there's Terminator,
yeah.
there's Robot Wars, there's a lot of fear about robots taking people's jobs and things like that. And that's doubly where it's very important when you're designing the robots to make sure that they're engaging, that they don't intimidate people. And you can look at my robots and say that there's no way that thing's taking my job. All right.
But you choose the form of a cartoon and cute.
So that one's the one that I showed you there is just a proof of concept one. The actual physical product that we're designing is using a slightly different form. Still designed to be cute and portable, but it's a bit more expressive than just a box.
Have you considered to have it more lifelike, like an animal? something
Yes
like that?
and no. Some of the products I've been designing are what I call soft body robots. So basically, it's sort of like you could say Teddy Ruxpin, if you've ever heard of that, but a plushy robot that will talk to you.
Okay.
But that's just one, right? Again, I'm not going to be able to make one product that everybody finds appealing, right? So you're going to have different approaches for the different age groups and the different use cases that we're talking about, because it's not just regular people who are doing fun things with robots. It's also the use cases where you are talking about senior care, people that are trapped in their own homes, or things like that, where you're probably going to want to have a slightly different form factor with different functionality and different capabilities,
Yeah.
right?
Yes, I understand. But on the other hand, the internals of the robot could be similar, and only the outside could differ a lot, so people can choose what the robot of their likings.
Exactly. So it's a matter of choosing your functionality and your form factor, right? So you need to have some variability there. A robot that's capable of monitoring a patient, right? To be able to maybe alert authorities if the patient falls, right? Or becomes unresponsive, or starts talking gibberish, or, becomes maybe shows signs of suicidal ideation. A robot that monitors that kind of behavior is definitely going to have different functionality and slightly different hardware than a robot that you're taking out in public with you, because you don't need to have that robot monitoring what's going on all the time. It's just responding to voice versus responding to visual cues, or a lot of different information that's being transferred, right? Because you don't want a robot that records everything and sends it over the internet to come out with you to the pub, right? Where there's a lot of different
Well,
conversations in there,
maybe
right?
the owner doesn't care, but the people around him don't
Well, the
do.
people around it would care. Plus, the robot wouldn't be very functional if it's trying to respond to everything that's going on, right? So you want things like one of the reasons why I chose to use Azure Cognitive Voice was because of the offline keyword. Google doesn't have that. Google Speech Services, it's complicated to try to implement, but with Azure Cognitive Speech, it's really easy to use that offline keyword, and that offline keyword does a lot to protect privacy. If there's something I want to talk about that I don't want my robot to hear, I just won't talk about the robot. And it doesn't listen to
Yeah.
me. It doesn't send that information over online, right? It only sends information online after I activate it with that keyword, or if I program it to respond to some sort of stimulus, right? A button press, or the appearance of a human
Yeah.
within the frame of its camera.
Yeah, that also takes care of, for example, GDPR like regulations.
Mm-hmm.
You're not sharing sensitive data to the cloud, to any cloud.
Like I said, not until you give it that explicit permission to by activating that keyword.
Yeah.
Right.
Simon?
Now, and that's where I started talking about, hey, do you want a model local, or do you want it in a cloud, right? Sure, you can put a large language model locally on a Orange Pi, which is about $100, and would fit in that form factor robot. However, currently, I think it'll change. I think they'll become more usable on commodity hardware. But the reason why we have to use an Orange Pi is because it has a Mali GPU, and it needs that GPU to do the calculations for the large language model. And it uses a lot of resource. That board uses about 6 amp max. And when it's doing using that model and running that model, it's using those 6 amps, right? So I'm sucking down battery. This guy right here, Raspberry Pi, two 18650s, right? At 1000 milliamp hours, it will run for about 3 hours on battery, which is pretty good, right? This is something, 3 hours is something I can take with me. I can walk around. I can do stuff with it. When I ran a large language model locally on Clippy, that sucked down that 3 hours down to about half an hour. Right. And that performance drain is partially because I had to really cool it down. I had to add more fans. That board sucking down 6 amps on its own, and I'm only getting 5 tokens a second. So if my response is about 100 tokens, how long does it take to generate that response at 5 tokens a second? All right. The performance is poor. And that's after it's been quantized, after it's been compressed, after, I'm rounding down all the floating points and the probability tables. It's slow. So, the performance versus benefit comparison on that was pretty poor. So yeah, we need to use APIs, but when we use APIs, we still want to make sure we're protecting privacy. We want to make sure that it's not recording things it shouldn't. It only activates the camera when I tell it to. When I tell it to take a photo, right? When I ask it to check something out or look at this, what is this, right? And I use things like image captioning to have my robot tell me what it sees, and then use that to inform alt text when it's going to post something on social media for me, right? But it only does that when I tell it to, when I explicitly give it agency to do so, and only for that task. And that's really important to keep in mind when you're doing AI and IoT, is to make sure that you're cognizant of making sure that when a person interacts with it, it's something they want. They want it to know, versus it recording everything, right? Which is my biggest problem with things like Alexa and Google AI, is that they record everything. Everything's sent over, right? And they're using all that data to train their own models and do advertising, right? So that's something I don't want to be part of my profit model, right? Mine is more just, not even the hardware cost, but like a subscription service to help pay for all that stuff that's going on in the back end.
Oh, Simon, I know you had your hand up there a little while back. You still got a question, or did it get answered? Or
Oh no, I was just going to say, I've got a little bit of experience with building conversational stuff that's voice based, and the other way that you make it engaging to people is it has to have some sort of screw up rate, right? If it's absolutely perfect all the time, boring. And if it uses the same phrasing for everything, you just get a wall of response. So one way that we found that making an intelligent personal assistant that way back used voice XML, and you phoned it up on a landline and pressed buttons and spoke to it and stuff, was that, it did say and hum and screw up the odd word. And we actually had to programmatically break some of the text to speech, because otherwise we found people would their comprehension just disappeared very quickly, because it was too good and it's boring and people don't listen to that. They need the breaks to process what's being said to them.
Yeah, a lot of the style guidance that I've worked with at Microsoft was, make it more conversational, less robotic, right? So the big problem that, like I said, I've been working on social robotics for about 5 years. And back in the beginning, when I take these social robots that I built to hackathon at Microsoft and talk to people like Satya Nadella about it, is that the technology just wasn't there to build a truly conversational robot. Even with conversational AI as it was with different chat tools like Power Virtual Agent and Azure Chatbot, things like that, because you built all these conversation trees manually that you could never really predict every possible phrase that would come in an appropriate response to that coming back out, even in general. Large language models change that.
Yeah, we
They
used to
give you
have
that
fun
ability. Yeah, and it does mess
with
up.
we used
You
to have
know,
fun with context as well. Like you'd want it to get excited about some things sometime. And when it's telling you about sports, shots in basketball are really exciting. Not so much in
yeah.
the
Yeah, you don't want to say, you don't want to be excited about a bill that you have to pay, right? Yeah, and that it is also true that, I mean, because when you start working with the chat tools like that, you're talking about using AI as a fallback, right? So you program all these decision trees to talk about the things that are important, that are domain specific, that you want your chatbot to be able to respond to in a very specific way. But for everything else that might come in that those decision trees don't cover, you fall back to a large language model that talks about generalities and is conversational. And the same approach can be used in AI, because I think like Power Virtual Agent or Azure chatbots can also be used with APIs, right? So you can sort of include them so that, let's say I'm building a robot for mental health care, right? I want it to respond very specifically to certain inputs, right? Like if a user is feeling suicidal, I want it to respond in a very specific way. So I want to have those sort of conversational components mapped out, right? Um, and I want to probably do it programmatically, because I'm going to want to pair that response that it gives verbally with an action it's going to perform in order to help the user, right? Versus fine tuning your model to respond in a specific way to specific input or general input, right? Which allows it to verbally respond in a specific way, but not necessarily respond programmatically with an extra functionality. So there are use cases where it would be useful to pair traditional conversational chatbot with conversational AI. But yeah, I actually worked on the chatbots for all the different um, Power Platform tools. So all the chatbots that you'd see were pretty much my responsibility, and you had to program it to fail gracefully, right? To give something that isn't robotic in response to something it didn't understand, or to an error condition that it would encounter, and still keep it functional while I did that. So it was always it's a fun challenge, part of the challenge to making those chatbots.
That was cool.
Let me see. Hey, Bimo. How are you doing today?
Oh, hello there. I'm buzzing along just fine. Thank you. Ready to assist you with anything you need.
So that's basically what the single QA pair is, right? It could do a lot of other things like I talked about here. On the Hackster IO site, there's some video just demonstrating some of that functionality they can do here, and a lot of the code is pretty self-explanatory with a lot of comments saying like, what this section is for. Like, here's the photo section. Here's the part where I let it describe what it's seeing using Azure Cognitive or Azure AI Vision captioning and things like that. So if you want to play around with it on your own, all that fun stuff's out there. If you want to try to port some of the code into the project you're using, it's pretty easy to do. And if you have any questions or anything else, let me see. I have a bunch of links in the slide deck that I can make available, including my contact information. And, like I was talking about, here's how to run a Red Pajama model on Orange Pi. Here's how to run Fast Chat on NVIDIA Jetson if you want to try to build a local model. And here's the builds for the API-based models that I was showing you.
So an Orange Pi because of power. I've lost track of Orange Pi comparison to Raspberry Pi.
Yeah, so Orange Pi uses a Mali GPU.
Ah,
So it's not the proprietary GPU that Raspberry Pi has, or the internal one. It's actually a discrete. And so they've been able to enable that GPU for the model. So the model can actually utilize that GPU, like how the fast chat does with the NVIDIA Jetson CUDA. All right. So here we have the Red Pajama model using or leveraging that Mali GPU on the Orange Pi 5. I should be specific, it's Orange Pi 5. But all the details about how to do it are sort of in this link here, and how to use the fast chat large language model on NVIDIA Jetson are here as well.
that's cool. I've got an NVIDIA Jetson sitting over there that's not been used since I did something with Paul DiCarlo quite some number of years.
I'm not sure if the Nano would be really reasonable for that. The response is still slow, right? It's a few tokens per second, but I mean it's usable. It's, you know, as long as you specifically tell it with the system prompt. So there's system context prompts that you send that the user isn't aware of, and then there's the user prompts that the user, it's easier input. And the system prompt is basically set the behavior of the LLM and tell it to, you know, how you want it to, how its voice style to be, how many tokens respond. Should you be concise? Should you be descriptive? Are you professional? Are you, you know, impersonal or friendly? All the fun stuff that you program the LLM to respond with is in the system, or the context prompt, as Google likes to say it. But yeah, you're going to want to tell it to be really concise and short in its responses with these sort of things when you're doing it locally.
Yeah, don't give me any answers that are more than about 20 tokens, please.
Yeah, pretty much.
Yeah.
Yeah,
cool.
some models are more attentive to the system prompts than others too, just to sort of put that out there. But yeah,
fair enough. Cool. Very good. That was excellent. Really enjoyed that. I see that it says the end on there, so I feel comfortable.
Well, I mean, if
enough.
there's any more questions or anything else, I'm more than happy to talk.
Yeah. And, you know, feel free to come off mute if you've got any other questions or anything you want to point out.
I think Sander has something.
Sander's always got something. That's why we love him.
Either that or that clap thing again, where it's not the hand raise,
yeah.
it's the clap. Yeah,
it was the clapping.
That one's going to get me every time.
It seems to be the clap.
Yeah.
There you go.
And this is the thumbs up. I cannot do them both.
Yeah, the hand up is like.
I mean, neither can I. That's sort of difficult, right? It's like
you'll be clapping your thumbs up. It doesn't look right.
Yeah, but yeah, my Microsoft background sort of comes up every time I use Zoom, because it's like, oh, there's a hand there. I need to stop because it's a question. No,
subconsciously programmed to do that now. Yeah.
Yeah, but like I said, you know, do I just send this to you and send it to the attendees, or? Yeah,
by all means, or feel free to stick it on SlideShare or whatever your chosen area is for these slides, and send me that, and I'm happy to tweet it out, or by all means just tweet out at NotsIoT, and I'll retweet it, or whichever you want. There's about a million different ways of doing it, but I know that you're not
easiest for everybody.
Yeah, send me the link and I'll send it out on Twitter, because I know we're more active than you are on Twitter, so I'll happily do that.
Yeah, I fled to
once you've
Mastodon.
uploaded them. Oh yeah, that's true. I've got a Mastodon account, but I forgot the password, and there seems to be no way to reset your password, weirdly. So I got a bit stuck and then gave up. I must go back and see if I can get in.
It always depends on what instance. You could always join another instance. I think I have like 3 different accounts there now, because I keep jumping around.
Fair enough.
I'm mostly on LinkedIn anyways, so
yeah, that's good then. Brilliant. Cool. Well, thank you very much. And we'll let you all go and drink Sander's beer, or whatever takes your fancy. And yeah, so nothing next month. But in November, do come back, and don't forget, you've still got time to to tweet on that hashtag NotsIoT, unless you're watching this on YouTube sometime later, in which case too late. But yeah,
Oh, hey,
thanks
yes,
so much.
Simon. Yeah, Jorvin's great. I love him. He's awesome. Odd J.
Oh yeah.
Yeah, I think he turned up at, was it open source in San Francisco recently, and was wandering around in the real world with a companion robot.
Yeah, I've been following him for a few years now. He's pretty awesome. But
Is that the owl? Kind of an owl looking thing.
that is
Kevin, isn't it?
that's
Oh, that's a
that-
lady, actually, I think, isn't it?
yeah, it's from
Kevin McNeil's got one.
Hackster.io. The lady from Hackster.io. What's her name? I think it starts with a J too.
Yeah.
But
Yeah, she's
yeah,
awesome.
she has the owl. Yeah.
Yeah. Good stuff.
Mhm.
Right, folks, we'll call it a night there. Thanks again to David for coming along, giving that talk. It was awesome. Really enjoyed that. And thanks to you folks for coming along and joining in too. Otherwise, it would just be me and David, which I'd still be happy with, to be fair, because we'd just geek out for an hour or two and I'd go away happy with that. But yeah,
I got to talk
share a
about
little-
digging holes for my beer.
Yeah, yes, definitely.
I'm going to go out and do that right now.
Yeah, you should. Yeah, you've got the light to do it, of course. It's very dark over here. You need floodlights, but yeah, excellent. All right, well, catch you all soon, and thanks again, folks. Appreciate it.
Thanks
Thank
for having
you.
me.
Thank you.
Thank
Cheers
you
then.
again.
Bye.